All right, so I want to look at one more example of telescoping series, example 9.1.6. Consider the sum from n equals 1 to infinity, 2 over n squared plus 6n plus 8. I want you to show first that 2 over n squared plus 6n plus 8 is the difference between 1 over n plus 2 and 1 over n plus 4. So that's good because there's no way if you have a single term to actually see any cancellations from one term to the next like we did in the last case. It's really important to have a difference of two terms. And so the first thing we do is we need to show that this is the same as what we have. Well, it's actually easier to go that way. So that way is just common denominator. To go the other way, to go that way, that's called partial fractions. And this is something we usually teach, but because we didn't have enough weeks this term, we're going to skip over it. But don't worry, we're not going to assume you know how to do this. And that's part of the reason I put A here is just to give you the answer. You can check if it's right, and then in B, use it. All right, so 1 over n plus 2 minus 1 over n plus 4. I'm going to put it together. That's n plus 2 minus, n plus 4 minus n plus 2 over n plus 2 times n plus 4. All right, common denominator is the product of the two. Then I take the cross to get the top. The top cancels nicely. I have only 2. And then if I multiply the denominator, I get n squared plus 2n plus 4n plus 8. And I do get 6n plus 8. That's right. All right, now determine whether the series converges. If so, find its sum. So we're going to do the same thing that we did on the last example. We're going to write the first few terms just to see if we can't catch any cancellation. I'm not going to write them in separate lines like I did here just because that takes a lot of time. I'm just going to start writing them right here. And once I see the pattern of cancellation, I'll know how many terms I need and I'll write the same amount at the back like this. All right, so let's look at Sn. That's going to be A1 plus A2. Let's see. I'm not going to write them this way. I'm going to write them that way because that's how I'll see cancellation. So we have, actually, let me put that first just to make sure everybody's following. I'm going to use AK is 1 over K plus 2 minus 1 over K plus 4 because we just proved it was the same as what we have. All right, so starts with K equals 1. I get 1/3 minus 1/5. K equals 2. I get 1/4 minus 1/6. All right, so we don't see the cancellation that we're hoping for, but it looks like the first term is getting close to this one, so probably the next one. Let's try K equals 3. I'm going to get, if I plug in 3 here, I get 1/5 minus 1/7. And then K equals 4. I get 1/6 minus 1/8. All right, let's try to understand this cancellation. If we see 1/5 cancels with the term 2 terms later. Same thing, 1/6 cancels with 1/6 2 terms later. Sorry, apparently I can't spell terms. Terms, oh, I missed it here as well. Oh well. All right, so once you see this, you notice that the second chunk that we have will cancel with a later term. All right, so let me write that here. 1/7 will cancel with the next one, and 1/8 with the one off after that. All right, so from the front part, we're going to keep 1/3 and we're going to keep 1/4. everything else will disappear. All right, now we have to figure out what sticks around at the back of the list. So here I'm going to add, I used 4 terms here, so I'm going to use 4 terms. So A3, A4, 3 dots. Then I'm going to start with AN, AN minus 1, AN, oops, AN minus 2, and then N minus 3. All right, let me lower this part so it lines up. Perfect. All right, so I have K equals N minus 3 to write. That's going to be 1 over N minus 3 plus 2. That's N minus 1. Minus 1, N minus 3 plus 4, N plus 1. And then I'm going to take K equals N minus 2. I'm going to get 1 over N minus 2 plus 2, 1 over N minus 2 plus 4, and then N minus 1. So I have 1 over N minus 1 plus 2, and 1 over N minus 1 plus 4. Oh, sorry. I want to do 3 dots, but we should probably write the next one too. My mind is getting lazy. All right, so at K equals M, we have 1 over N plus 2 minus 1 over N plus 4. All right, we've written all the terms we need. Let's see if we can't figure out cancellations. All right, so I'm going to use, let's use green. So N plus 2, yeah, cancels with 2 further out. So 2 terms before, N minus 1, 2 terms before. And so here, the second chunk, the first chunk, sorry, cancels with 2 terms before. So that means that N plus 1, N over 1 will cancel with the first term I didn't write. So cancel with previous term, and then previous term singular, and then N minus 1 will cancel with the one before that. All right, so what's left? Well, I have 1 over N plus 3 and 1 over N plus 4. So Sn is equal to 1/3 plus 1/4 minus 1 over N plus 3 minus 1 over N plus 4. And so S, which is the limit as n goes to positive infinity of Sn, will be the limit of these. The last 2 terms go to 0 because I have 1 over infinity. So this is 0, this is 0. So I get 1/3 plus 1/4, which is 7/12. So the series converges to 7/12. All right, so you can see the pattern of cancellation. You write the terms that are left, you take the limit, you make sure that that's a number. If it's a number, the series converge. If it's infinity or bounces around its D&E, then the series diverge.